Good morning, students. Today we are going to continue the last session. In the last session, we finished up the unconditional branch instructions. So, in the today's session, we are going to start the conditional branch instructions. So, just before starting the conditional branch instruction, in the last class, we discussed about the compare instruction. So, the main intention of the compare instruction is in order to check it out whether the destination is greater than the source, destination is less than the source, destination is equal to the source. Why I took that instruction means in order to explain how exactly the conditional branch instructions are going to be um, what we say executed by the microprocessor. How we are going to make use of the conditional branch instructions in our program. Okay, now, so in order to check out that one, I took the CMP instruction. So let us take the explanation for that. Okay, so here I'm just writing one program. I'm writing one program. I'm going to take the middle of the one. I'm just performing the move AL comma 06 H move BL comma 09 H and simply use the CMP compare instruction AL comma BL, and after that see here after comparing the AL with the BL, obviously AL is called as the destination, BL is the source. So AL is less than the BL, but I am expecting that AL should be greater than the BL. Okay now. So we have seen certain condition na compare instruction. When the AL is greater than the BL, AL is greater than the BL, then obviously carry flag equals to the 0. Means we are supposed to look for the carry flag equals to the 0 or not. If the carry flag is not equals to the 0, then obviously AL value is less than the BL. I'm not going to write all those things again. In the last class we have seen that one. Okay now. So here what is that? Okay, let me take them also. What is that? If the destination is greater than source, then obviously carry flag equals to the CF equals to the 0. If destination is less than source, then carry flag equals to the 1. Okay now. So here in this example what I am assuming is, I am assuming that AL is the destination value, which is the AL, is always greater than the BL. If the AL is not greater than the BL, if the AL is greater than BL, what we are supposed to do? We are supposed to look for the carry flag. Means whenever the destination is greater than the source, then carry flag should be equals to the 0. If at all the carry flag is not equals to the 0, means if the carry flag is not equals to the 0, means it is obviously the destination is less than the source. At that time I would like to take the source into the destination register, because the source is greater than the destination. Okay now. So here I am simply, so what we are supposed to do, we are supposed to simply look for carry flag carry flag equals to the 0, carry flag equals to the 0. So soon after the comparison operation is over, then I am expecting that carry flag equals to the 0. Okay now, for that I'm the means carry flag equals to 0 means I'm just taking one conditional jump instruction, which is a JNC, jump on no carry. When the CF equals to the 0, jump. Okay, so jump on no carry. I'm just taking the label. Okay, so if this one is not happened, so means if the source destination is not greater than the source, so here if the destination is greater than the source, we don't have the carry, so obviously JNC instruction is going to be true and no need to take the BL value into the AL. But here AL value is less than the BL, or otherwise if the carry flag equals to the 1, not equals to the 0, and it is equals to the 1, then obviously BL value is greater than the AL. So I would like to read the BL value into the AL. So for that I am just writing one instruction like this. Okay, so I'm going to write move. If at all there is a carry, no carry we are looking, but if there is a carry, then AL comma BL. Obviously BL value is greater than the AL. So here in this case what you are supposed to do means you are supposed to take the label over here. Okay now. So label, let me take one more step out. Okay. label colon. What is the termination of the program? int03h, int003h. Okay, so here if you see this one, whenever there is no carry, obviously AL is greater than BL, then I'm going to terminate the program. If there is a carry, then I would like to load the what is that source value into the destination. So I'm doing that one using the move instruction. So BL value is copied into the AL because there is no carry we are looking, but obviously there is a carry because the AL content is 6 and BL content is 9. So obviously 6 is less than the 9. 6 is less than the 9 means there is a carry flag. So when there is a carry flag, obviously the condition fail. When the condition is fail, then it is going to be executes the next instruction. So it is going to be executes the next instruction. If at all the condition is true over here, then it is going to be jumps to the label address. It is going to be jumps to the label address, means from here to here it is going to take the jump. Okay, so that is what the explanation of conditional branch instructions. So means unconditional branch instructions means which diverts the execution control from one location to another location without checking any condition. But here in case of the conditional branch instruction, if at all the condition is true, then only it will divert the execution control from one location to another location. Otherwise, if the condition fail, then it will execute the next instruction next to the whatever the instructions which are there next to the conditional branch instruction. Those instructions get executed by the microprocessor. Okay, now so this is about the conditional branch instructions. Okay, conditional branch instruction. So the next case is I'm going to finish it off as early as possible because it is that we are taking more time. So here the next case is iteration control instructions. So what exactly the iteration control instructions means? The set of instructions which are used for executing the a group of instructions for finite number of times. Otherwise, simple cases how we are performing the for loop, do while loop, and while loop. Okay, now the main intention of the loop concept is to execute a group of instructions for finite number of times or the count number of times or the condition up to the condition satisfied. Okay, now so to do that kind of operation, that loop kind of operation, we are having the instructions in 8086 microprocessor called as loop e, that is a loop equal or loop 0, loop not equal or loop not 0, and jump on 0 means whenever the cx value becomes the 0, then takes the condition true, jumps to the specified label. Okay, now so these four instructions, let us see those four instructions explanation, how exactly they are looking. Okay, so we are having the loop now. So loop is a loop instruction. Whatever the iteration control instructions we are having, we have seen these instructions. All these instructions are taking the cx content as a counter register. Cx content as a counter register means if at all you are taking one loop instruction and trying to make use of that instruction as a part of your program, that loop instruction is going to be work based on the content of the counter register, which is a cx register. Counter register, which is a cx register. Upon execution of every instruction, means if I am taking one instruction and executing that instruction, then it decrements the cx by 1 and check it out whether the cx equals to 0 or not. If the cx is not equals to the 0, then the condition is true, again jumps to the label address. Okay, now so what I mean to say that they're having the loop instruction, right? Loop instruction. So the syntax for this one is a label. Loop label means it is going to be jumps to the label address. I'm just writing the comment. How it is performing means whenever the loop instruction got executed by the 8086 microprocessor, at that time it will decrement the content of the cx register by 1, and after decrement, if this value is not equals to the 0, if it is not equals to the 0, I think I don't have the not symbol. Okay, if this one is okay, if this one is not equals to the 0, after decrement operation, if this content is not equals to the 0, then obviously condition is going to be true. Okay, now means upon every execution of the loop instruction, upon execution of loop instruction, it will decrement the cx by 1. If this cx now content after decrement, whatever the result you are getting, If this result is not equals to the 0, then obviously condition true, it will jumps to the label address. It will jumps to the label address. Okay now, so that is the main intention of the loop instruction. So loop instruction main intention is to execute a group of instructions for finite number of times. For that, what I'll do is I'll take one simple example for this explanation. Okay, so with that, with that I'm going to finish up this. Okay, so loop instruction, I would like to explain the loop instruction. So I'm just performing the move al comma move al comma 03 h plus move bl comma how much 03 h only. I'm going to take the cx register because how many times I would like to repeat the loop operation. I'm just taking the cx move 0006 h. Otherwise, let me take the 2 for the explanation point of view, 2h, followed by, I'm just performing the add operation between the AL and BL. I would like to repeat this add operation for 2 times. Then I'm going to make use of the loop instruction. I'm going to make use of the loop instruction L. I'm assuming the label is a L1. Okay, so I'm going to take this label, okay, L1 colon. So this label L1 colon, and finally I'll come back to termination of the program, which is int 03. Okay, so this is my program. What is my program is I took the two values into the two 8-bit registers, which are nothing but AL and BL, and I'm taking one counter register and I'm loading that register value with the 0002, and I'm performing the addition between. Means I would like to repeat this add operation for 2 times. So for that I took the loop operation. I took only the 2 for the explanation point of view. The how many times you would like to perform, that depends on that depends on your interest. Okay now. So how many times you would like to repeat the add operation, that should be taken as a count value, and that value should be loaded into the counter register. That value should be loaded into the counter register. So here in this case, first it is performing the AL with the adding the BL content with the AL, and final result is there in the AL only. And here, when this instruction got executed by the microprocessor, at that time this one is going to be decrements the cx minus 1, cx value by 1, equals to the cx value previously how much we took, 2. So it is going to be 2 minus 1 means, so obviously it is going to be the 1. Result of this operation is going to be the 1. Is it equals to the 0? No, it is not equals to the, sorry, shit, okay, it is not equals to the 0. Wait a minute now. Wait a minute now. Now let me rewrite that operation. So we are supposed to take the loop value, right? Count value. So here it is performing the addition operation. So upon execution of the loop instruction, it will decrement the cx value by 1, right? It's going to decrement the cx value by 1. So cx minus 1 equals to the how much? 2 minus 1. So cx value is a 2 now. 2 minus 1 means the result is going to be the 2, 1. It is not equals to the 0. So it is not equals to the 0 means, as the 1 is not equals to, the result of this operation is not equals to the 0, it is a 1, it is a non-zero value, so obviously condition is going to be true. Condition true means this was jump is going to be takes to the means microprocessor jumps to this address. Okay now, executes the add operation one more time, and in the second case, what will happen? Again the cx is decremented by 1. Again the cx is going to be decremented by 1. So Cx minus 1. Previous value of the Cx is how much? 1. This is the result. This is the result of the previous operation. Now. So Cx minus 1 means previously 2 minus 1. The result is a 1. This one is stored in the Cx register and it is not equals to the 0. Now Cx value is how much? 1. 1 minus 1 equals to the 0. 1 minus 1 equals to the obvious